As mentioned earlier, perhaps the most powerful and elegant of the probability distributions for frequency is the Poisson distribution. The Poisson distribution, as a reminder, only requires one parameter, lambda, which is the mean frequency. In other words, how many times per unit of time, per year, per month, a phenomenon occurs on average. For example, imagine that in this project there's a history where the average number of natural damage events, storms, floods, etc., is 3 per project. Using this parameter, lambda equals 3, we could generate a Poisson distribution that would articulate a frequency distribution, showing the probability of encountering each of these scenarios. Another example could be conflicts with the local community. If there's historical data, or at least the judgment of an expert, they might say that on average they would expect to have about 5 conflicts. It's not necessarily going to be 5, it could be 3, 5, or 10. But what the Poisson distribution does is that by using a single criterion, lambda equals 5, we articulate a probability distribution that spreads various probabilities, which, when simulated many times, will result in an average of 5. This allows that, with just one parameter, lambda, to articulate a frequency distribution that enables us to generate the frequency. That is, how many times per year or how many times during the duration of a project a phenomenon like natural events, conflicts with the local community, or any other type of risk event frequency would occur. This can be calculated either with historical information or the judgment of an expert using an average value. We take the average value, that's the lambda, we input it into the Poisson distribution, and through that, we can articulate very powerful frequencies for risk events. In the cloud application, you just need to select the Poisson distribution for frequency, input the corresponding lambda parameter, for example, 5 community problems per year in the project, and obtain a probability distribution of how many events we would expect. For example, in this case, we would expect that given a lambda of 5, there's a 0% probability that no events will occur, a 3% probability that one event will occur exactly, an 8% probability that 2 events will occur, a 17% probability of 4 events, and also a 17% probability for 5 events. Given a lambda of 5 events per unit of time, the probability of having 10 events or even more starts to decrease, dropping to less than 2%.